Okay, hi everybody. So let's just jump right in. So as we discussed in class, we have collected our data. So now what? We analyze it. And there are two types of statistics that psychologists use. Again, they use both of them, not one or the other. Descriptive statistics are going to help us to analyze the data of our sample, the sample that we studied. So descriptive statistics are going to tell us, or going to answer to the question, how does my sample look like? And we can't do basically anything. When we collect the data, we just have a bunch of numbers, as you saw in your spreadsheet from the data we collected from both sections of AP Psych. As you may see, it was interesting because it was your data, right? And we were looking mostly at individuals. But as a group, it was very difficult or time-consuming, let's say, to see the tendencies, how our sample, in this case, your data that we collected from you, it was basically very time-consuming to see the tendencies as a group. How was the behavior or the information from the group? But descriptive statistics help us. And that was the raw data, what you saw in your spreadsheet that I copied for you. So descriptive statistics are going to give us an easier way to detect any trends, to identify the main behavior or behaviors of that data. And it involves following concepts. And there are more, as you will see in the slides. But when we talk about frequency distributions, graphs, percentile, central tendencies, or measures of central tendency, variability is the same thing as dispersion, measures of variability or measures of dispersion. We're talking about descriptive stats, meaning anything that helps us summarize the data that we have collected from the sample. It tells us nothing from the population yet. So let's begin with graphs. There are several graphs in statistics. The purpose of graphs is to organize information and to illustrate it, meaning it gives us sort of a picture. Instead of providing us, I want to make a comparison with, imagine somebody describing to you where they went in the summer, and they are describing a very nice beach, and they are telling you, right, everything, and you imagine it. But you have to put all the pieces together in your imagination. They might be great describers, but very likely you have to, make some effort to really imagine and capture the essence of that place. However, it would be much easier if they showed you an illustration of it, meaning a picture. And that, of course, is the same thing what graphs do with our data. They give us a picture in one snapshot. They give you the information of, and you can easily see what data can stick out depending on what research question you're trying to answer. And there are several types of graphs. We have frequency distributions. We have frequency polygons. We have bar graphs, pie charts. It is expected of you to understand, to identify which one is a frequency distribution, which one is a frequency polygon, and so forth. But most importantly, you are required, or it is expected of you, to know how to interpret data from a graph. This is also very useful for anybody who is going to or who is taking AP languages. Since I taught AP Spanish, I do know that this is also something important for these tests as well. AP Spanish or AP French, you are required to interpret data. It's an important part of the critical thinking curriculum and your requirement of being critical thinkers to see a graph and say, okay, well, I can immediately see this, and that, this sticks out to me, and to compare within the same graph different types of data if they're comparing, let's say, gender or ages, etc. The following distribution is actually real data. And as you might see, Frequency distributions are basically tables in which each rectangle, the thing is here for the, I guess for the purpose of style they don't have, but it's supposed to be, or the spreadsheet is supposed to divide, to have in each cell in each rectangle, in each cell, there is a numerical value. And that numerical value is supposed to summarize the tendency from the data that was collected. This research question has something to do with what induces teenagers or high school students to engage in illicit drugs. And they are also comparing public and private schools. So this is a quasi-experiment or a correlational study. It looks more like a quasi. And if you just basically pay attention to the legend, it will be very easy to read. N is usually the number of people in the sample. This is raw data. Again, it's important to know that term, raw data. And N tells us the number. Think about it as terms of N, lowercase, those number of people usually. Or number of behaviors, but usually it refers to number of people within a sample. Here the options are, or the variables that were measured in the survey study. Oh, it could have been a survey study too, or a survey used for quasi. That's not entirely relevant right now, but here were the options. So whether it is curiosity that triggers drug use, desire that triggers drug use, and so forth. So they went and they selected, they have two samples. So this is a between groups study because they are comparing two groups, public schools versus private schools. And they selected 6 public schools and 4 private schools. In one section, they were the question about how can they compare different samples. Yes, it can be done, thanks to statistics, because they tell us, okay, if this is what you found, then this is what you need to do, and we'll see that when we go into inferential stats. But this is not a confounding variable. And in fact, if you look at the population in general, more kids go to public schools than to private schools. So very likely that had to do with the fact that they selected more public schools in their samples than private schools. Now, thanks to Joe in section 1, shout out for you, Joe. He really, his logic makes sense in that very likely the survey was conducted in a way that they went to these schools, asked first the students, perhaps they asked everybody in the school in high school, or every senior or every junior and senior, if they engaged in drug use first of all, right? And then if they said no, then likely it said, well, then go on to question number 10. And if they said yes, then go on to question number 2. I'm sure you've seen surveys like that. And then, in these 6 public schools, they found that 472 students perhaps engage in drugs regularly, and from the 4 private schools, 632. That was their total sample for the N for private schools. And then this is the data described in terms of, because it doesn't make sense to report those students that do not engage in drug use if the question is only what triggers drug use. I'll explain one. So let's go with the public schools. What is it what is the factor that is most powerful in triggering, or that is most often a trigger for drug use in public school students? You can see that it says influence. Likely this is referring to influence of others, peer pressure, friends. The influence of friends, 182 students reported that, which means it's 38.5% of 472. How do I know that? Because it's right next to the 100% right here. So let's compare that same influence factor as a trigger with private schools. Only 92 students in private schools says that influence is what triggers their drug use. The most popular answer here, actually it was fun, sorry. sorry. So if it is fun in public schools, the highest one, right, then that's 41.5% of the sample, and it coincides with the number one trigger for drug use in private school students, high school students, and that represents a 36.6 part of the sample. So here we have an interesting comparison that can be made. So just so you know, when I ask you to interpret frequency distributions, you can say that actually public school students and private school students, based on the sample, the data of the sample, consider fun to be the main motive or the main trigger for drug use. And then so forth. And then you have here usually frequency distributions at the very end have a total in which it serves as a I'd say not a baseline, but as a reference for the whole population, because as you might see, 472 plus 632 should be 1,094. This is the total of N of the entire study. So that's basically frequency distributions. This is a very interesting one that I found, actually. It's from the Pew Research Center. They have great surveys and they're very professional. And I will ask you, either in a test or in a quiz, to write a headline for, perhaps I'll give you this same data, but, without the headline, and for you to write it, because basically what I would be asking with that exercise is for you to sort of look at the data and see what is the most important information, what is the most relevant information from the data collected from the sample. So usually it's very important to read the legend, and here the sample usually says N equals 1,060 or 1,060, and it's teens, ages 13 to 17, and this survey, I think, is to rate the acceptability of each method of breaking up. So how acceptable is it to break up with somebody else on the scale from ranging from 1, which is least acceptable. Anybody who rated any of these ways to break up with somebody else is not acceptable at all, and 10 is the best way. So here are the different ways, the main ways people can break up, or the tendencies of that's seen in the population today of people breaking up from romantic relationships. And which one was the most acceptable among teens asked, surveyed? How many teens said that the most acceptable way is tell them in person? Or I could ask you, what would be the most acceptable form according to the sample? It would be to tell them in person. Now, something tells me that this, I think, is easily generalizable to the population. I think that any other way to break up with somebody, well, call them on the phone maybe. But I'd be curious for your opinions in class when we discussed. I think it's very interesting. All right, so I'll ask you some questions later on about this, but I'll give you some time to think about it as well. This is, again, a frequency distribution. It's a chart where that organizes the information, tells us, I remembered now. Frequency distributions are basically a tally. How many said yes, how many said no, how many rated 10, how many rated 2, how many rated from 10 to 6, and again, an easy way to organize the frequency distributions, help us organize the raw data. The next graph is a bar graph. Oh, sorry, this is not a bar graph, and this is my mistake, so I'll cross it out. Make sure you write pie charts. And poly students love pie charts based on the senior plans I've had to sit in. I said in class that usually pie charts are not recommendable. That is to a certain extent, I sort of have to take that back a bit. It's the 3D pie charts that are a little complicated because you have to go back to the legend, go back and forth. So basically what I was trying to say there is that the way you present the information is going to definitely have an impact of the strength of your message. So if you want people to pay attention to you and to understand what you're saying and to engage, you have to be very careful with presenting very clear data, identified data. You have to label everything that is in the data. And usually it's important to place a source. I can't tell you the amount of students I keep seeing in senior plan just, not identifying anything, and that is not right. And again, please make sure you seniors and you juniors for next year that you do that. Okay, so it's a very simple one. It says among the Facebook users, the percentage of the following number of friends in their network. Yeah, I would like to compare this data with the one we collected from our sample. Let's see if because this was a survey that took place a while ago, 2012, and these are teens ages 12 to 17. They surveyed 882 teenagers ages from 12 to 17. So take a look at it, and I'll ask you some questions about this as well. The following graph is a frequency polygon. And why a good way to remember it is that the reason why it's called polygon, and in some cases they do this, is that they from the intersection between the x and the y-axis, the 0 point, the very beginning, which represents no data at all, for each one of these polygons, I can close them, right, at the very end, at the very beginning and end. And what we have here is this area right here sometimes is colored all the way, and that's, you have a polygon. You close it, but the more I've seen lately are not closed, but just so that you know how to remember how they are called. And this one is a more complex one than the previous data we've seen, but it's still easy to understand, again, because they have a clear legend. Here we have if we read the title, it says the percentage of teen and adult internet users who use social networking sites or Twitter over time. So my guess is that they're trying to see how Twitter compares with the rest of the social networking sites like Facebook or, Instagram, you name it. And then, I don't know how people have time to just, have these current all the time. It just is very time consuming. So then the dotted line, right, is adults using social networking and teens using social networking. And then we have then the lighter blue continuous line is teens that use Twitter, and the dotted lighter line is the same thing with adults using Twitter. So in 2006, so it progresses the x-axis. Notice its tendency of putting in the x-axis, they're putting the years. They're progressive years, and in the y-axis usually is the amount of people in terms of percentages or the raw numbers of people that answered in a particular way. In 2006, we can see that 55% of teens from the ages of 12 to 17 again, the amount of teens that were surveyed that used social networking sites in general were 55% of them. Only 16% of adults that same year reported using some social networking sites. All right. Then in terms of using Twitter, no teens were using Twitter, nor adults. No adults were using Twitter either in 2006. When we begin to see data for the fours, actually in 2011, when 80% of teens were using social networking sites. My guess is that probably it includes Twitter in this 80%. But from that 80%, Let's see, teenagers were here, right? Yeah, I would say here, around this area. 16% would use Twitter from those 80% that use social networking sites in general, versus 12% of adults were using Twitter at that time, and whereas adults using social networking in general was 64. So again, I'll be asking you questions, try to look at it, try to see what conclusions, what trends can we see, what comparisons between the two groups that were surveyed. Those are things to look out for when evaluating any of these types of graphs. I forgot to mention that histograms are another graph, and I just realized that I forgot to include one, and I think it's also very important. And histograms are a bit different from what do you call it? They're going to seem similar, but they're very different from, what did I just say? Bar graphs. Because a histogram, a frequency polygon, can also be presented in a histogram form. And the histogram consists of bars, right? But usually it's the same thing, but in this case, if I wanted to present the same data with a histogram, then the line here, the dot, where the line begins, has to be in the middle of the tower, right, or whatever, the bar, sorry, tower. And then perhaps a different color would go this way. So you can see the difference between adults and youth. And then the next, so you have the 60% here, 60% here, can't be all the way there, because again, it has to hit the middle of the bar. And then you have adults here. So if you wanted to draw a histogram, it would have the same form, but instead of having lines, you would have these bars. Now, notice that in histograms, the bars are going to be, this is very important, the bars are going to be together, right? They're inseparable. They're going to be, so, they're going to be like this, right? They're together with one another. If we look at bar graphs, so you can see that they're together. If you go back to the bar graphs, then you're going to see that there's some space in between. There's some space in between. Why is this? Okay, pay attention. Histograms, the variable that's in the x-axis, in the y-axis, have to be continuous variables, meaning what we call ordinal, at least. Ordinal means that you can order them from lowest to highest. And the last graph we'll see are bar graphs, very commonly used, very clear, in my opinion, are and not only in mine, and many other opinions agree with me that these are the clearer ones. This is positioned in a horizontal way. I keep seeing more the vertical ones, so this is why it's you have the title written in that position. Usually we go this way right here, but here it says percentage of teens with current or prior romantic experience who have broken up with someone or been broken up with within the following ways. So again, you have the dark blue represents teens that have broken up with someone else. They have initiated that awkward conversation, and the light blue have been broken up with. Somebody has broken up with them in a certain way. So in person is the trend that definitely old-fashioned in-person breakup continues to be the most popular trend, and then they take it from there. Remember, it's important to know that this is percentages. So 62% of those interviewed have experienced breaking up with someone else, and 47 another person has broken up with them in person. The least popular one. Now, this is very different from the first one. The other one was, again, you have to be very clear how they rated it, how they considered it an acceptable way. Here, it's just basically who has experienced this. So that's about it. If you take a look at the bar graphs, you have variables that cannot be in order. Although in person could be most acceptable, Still, breaking up with someone in person is not something that can be more or less than breaking up with someone with a phone call and so forth. These are categorical variables, such as, hopefully you remember when we were seeing that, your political affiliation could be a categorical variable, because, being a Democrat cannot be more or less than or twice as much as being a Republican. Of course, subjectively, we might disagree, but that tried to be a joke, I guess. Not very funny. But you get hopefully you get what I'm saying, that these are categorical variables, or nominal variables, as we call them. Nominal. Let me write it here. Nominal versus ordinal. And there are other types of variables that have an order, like numbers or age or so forth. Temperature, ratings. Again, they're continuous.